Okay, before we leave projectiles, I want you to do one more example. Just because we didn't have time to do it before the lab today, but had we, I would have given you this one. So give this one a try. You're on the roof of a building, 8 meters above the ground. You kick, I don't know, a soccer ball, a football, whichever you would like, with some initial velocity at some angle. It goes up, it comes down, it lands 12 meters away. I would like you, and the time that it takes in total is 4 seconds. I would like you to find the VI and the theta. Okay, so pause the video, work on it, and then come back and I'll do it with you. Okay, so stop the video now. I'll wait. All right, so hopefully you did stop the video. Hopefully you tried it. Hopefully you were successful. Let's see. So VIX is going to be VI cos theta. AX is going to be 0. Delta dx is going to be 12 meters. And delta t is going to be 4 seconds. In the y direction, VIY is VI sine theta going up. AY 9.81 meters per second squared going down. Delta dy is going to be 8 meters going down, and delta t is going to be 4 seconds. Now there's a whole bunch of ways you could do this. You could actually solve for VIX, don't break it into VI cos theta, and you could solve for VIY, and then you could find VI and theta. You could also use the little tan theta technique that we've been doing. And I was going to give it to you today just to see if you could figure out which one. The good news is both of them work, okay? So if you do the tan theta one, this will be delta dx is equal to VI cos theta delta t, and you can't find it. If you left it as VIX, you could find it. You have both delta dx and delta t. But if you went and expanded it out here, now you have two unknowns. And so you would have to go to delta dy, which is equal to VIY delta t, 1/2 AY delta t squared. And you could actually find this here. The only thing you don't know in this equation is VIY. But if you expanded it out into VI sine theta delta t plus 1/2 AY delta t squared, now you can't solve it. You have two unknowns. So I really wanted to show you this to explain there are different ways you could solve. And sometimes it's good to break it into VI cos theta and VI sine theta, but sometimes it isn't. If you don't know either the VI or the theta, sometimes you're best at leaving it as VIX and solving for that, and VIY solving for it, and then putting them together like in the Pythagorean theorem to find your VI and your theta. But if you didn't do that, you could then rearrange this for VI. So it would be delta dx over cos theta delta t. And you could fill it in over here. So delta dy is equal to delta dx over cos theta delta t times sine theta delta t plus 1/2 AY delta t squared. And the delta t's will cancel, and the sine over cos becomes tan. So delta dx tan theta plus 1/2 AY delta t squared. And this time it's tan theta that you're solving for. So it would be tan theta is equal to delta dy minus 1/2 AY delta t squared over delta dx. And then you would fill your numbers in. The delta dy is 8 meters down, so negative 8 minus 1/2 negative 9.81 meters per second squared times 4 seconds squared over 12 meters. Okay? And so the first term is negative, but this second term, 16, will end up being positive. So you'll get tan theta is equal to positive 5.873. Do inverse tan and get theta to be 80.337 degrees. So you kicked it pretty steep. Then you would go over here and fill it in. VI is equal to 12 meters over the cos of 80.337 times 4 seconds. And when you do this, you should get 17.8736 meters per second. Okay, so two reasons I wanted to give you this example. One was to show you how sometimes you can make life more complicated if you separate the VI x and VI y into VI cos and VI sine. And that is when you don't know your VI and your theta. But you can still solve it by subbing in. Obviously, it would have been easier here to just do 12 meters divided by 4 and get your VIX to be 3 meters per second. And then over here, subtract your 1/2 a delta t squared and divide by delta t and get your VIY. And then do Pythagorean theorem in the angle. But this also still works. Okay, so on your test tomorrow, there will be some multiple choice, no theory. There will be probably a couple of horizontal projectiles, probably 2 or 3 ground to ground, and 2 or 3 non-ground to ground, right? Because remember, the non-ground to ground, they can start from higher up and then lower down, vice versa. Ground to ground, we had a few different things to find. So there'll probably be 8 calculation questions, okay? All right, very good.